Bismillahirrahmanirrahim. This is your chemistry teacher Farzana Nazir. Today we are going to continue our chapter 4, Structure of Molecules. Today I am going to teach you how to draw the structures of covalent molecules and how similar and dissimilar atoms they are bonded together to form a covalent bond. In this lesson I will teach you more about concept of covalent bonds. We will study different rules for drawing covalent molecules, and in the end we will draw cross and dot structures of covalent molecules. The learning outcomes of this chapter is that by the end of this lesson, student will be able to understand the concept of octet and duplicative rule, explain how elements attain stability, describe the formation of covalent bond between non-metallic elements, and they will be able to draw electron dot and cross structures for simple covalent molecules containing single, double and triple covalent bond. Students, as I have already told you that covalent bond is always formed between non-metal atom. Here are some examples of different covalent compounds. When you have two non-metals together, neither will give away its electron, so they share their valence electron to form a covalent bond. Covalent bonding make molecules in which specific atoms join together by sharing electrons. There are two kinds of molecules: molecular compounds which are shared by different elements, for example HCl, H2O, carbon dioxide and ammonia, etc. And the other type is of diatomic molecule which made up of same atoms like oxygen gas, hydrogen gas represented by O2, H2, etc. Now we are going to study some rules for drawing the covalent molecules. First rule is that find the central atom. A central atom is the atom that contributes more electrons for sharing. Show its valence electron by dot. Rule number 2 is note the number of electrons it needed to complete octet. If the number of electrons needed equals to the other atom, each atom will form a single covalent bond. Arrange other atoms around the central atom. Use cross to represent electrons of the other atoms. Check whether the arrangement of electrons satisfy the octet rule. Now let's have a look of hydrogen ions. The nuclei of the hydrogen ions propel each other, but they are attracted to the electrons. So these electrons are shared between the two nuclei, keeping hydrogen together as a diatomic molecule. Now let us try another example of fluorine molecule. Fluorine has 7 electrons in its outermost shell. It requires 1 electron to complete its octal. Here is another fluorine. To become stable, both the fluorine they will share their electrons in their valence shell, so that both the fluorine atoms have 8 electrons in the valence shell, and fluorine becomes stable as F2 molecule. Now here is another example of water. Water is formed with covalent bond. Each hydrogen has 1 valence electron. It needs 1 more electron to achieve noble gas configuration helium. Oxygen has 6 valence electrons. It needs 2 more to achieve noble gas configuration. So they share their electrons to make each other happy. Hydrogen have its electron with oxygen to become stable, but oxygen still have 1 less electron, So we take another hydrogen atom and bond to oxygen atom. Now each has full valence electron. Next example is of carbon dioxide. Carbon has 4 electrons in its outermost shell. Oxygen has 6 electrons in its outermost shell. It needs 2 electrons to fill its octet. Carbon is the central atom. So when we attach one oxygen atom, it leaves the oxygen one short electron and carbon with 3 short electrons. As you can see in the picture. Attaching the second oxygen leave both oxygen short of 1 electron and carbon with 2 electrons. The only solution is to share more electrons, so carbon dioxide makes double bond. Carbon and oxygen will share their unpaired valence electron, this thus forming the double bond. Now carbon has 8 valence electrons and oxygen on the left has 8 electrons and oxygen on the right also have 8 electrons. Next example is of ammonia. Formula is NH3. According to the formula, one nitrogen combined with 3 hydrogen atoms to form ammonia. Nitrogen have 5 electrons in its valence shell. It needs 3 more. Hydrogen ion has 1 electron each and need 1 more electron to become stable. So we have 4 atoms with 3 bonds. So we will bond each electrons to nitrogen with 1 electrons of hydrogen. Nitrogen has 8 electrons in its outermost shell and is stable. Now another example is of cyanide. Cyanide consists of carbon, hydrogen and nitrogen. Nitrogen has 5 electrons in its outermost shell. Hydrogen has 1 and carbon has 4. Carbon is the central atom because it needs maximum number of electrons to be shared. Therefore, it will be placed at the center. Hydrogen has 1 electron. This electron of hydrogen is shared by the carbon. Nitrogen, when it shares 1 electron with carbon, both the nitrogen and carbon has unpaired electrons. Therefore, to become stable, carbon and nitrogen will share their remaining electrons, forming triple bond.